We're going to talk about graphs of tangent functions and cotangent functions here. We're going to first start investigating what the graph of y equals tangent of x looks like, and we'll make some decisions from there. And so we keep in mind that tangent of x is sine of x over cosine of x. And so let's do some plotting of some points. Let's calculate some points. So because I have an idea, of course, what things are going to look like, I've chosen x values starting at negative pi over 2, and then I've gone by pi over 4 units. So I went negative pi over 4, and then 0, and then positive pi over 4, and then pi over 2, which is pi over 4 more. Go pi over 4 more, I'm at 3 pi over 4, and then at pi, and then 5 pi over 4, and then 3 pi over 2 is pi over 4 more. And as you can see, for each of those x's, I calculated the sine values, which you can easily verify. That's no problem. And I've calculated the cosine values as well. Now, our y, if we're graphing y equal tangent of x, our y is sine x over cosine x. It'll be the number here divided by the number here, and you can see immediately that's a problem because dividing by 0 creates an undefined fraction. So all I've done is gone through and taken sine x divided by cosine x, sine x divided by cosine x, sine x divided by cosine x, all the way through. And I got these results, which of course is the same as the tangent of these x values. And so if I use these x values, then when I'm graphing y equal tangent of x, these are my y values. And of course we clearly see that some of these y values are undefined. Now, also notice that the distance between these undefined values and the y values between the undefined values are repetitive, negative 1, 0, 1, negative 1, 0, 1. And that gives us an indication, which is the case, that the period of the tangent function is pi units rather than 2 pi units like the typical cosine function or sine function. So the tangent function has a complete cycle up here in pi units as opposed to 2 pi units. And so we need to pick out our home interval. And for the sine function and cosine function, the standard functions, we chose our home interval to be between 0 and 2 pi. Here we only need to be pi units long, but if I start at 0, I have an undefined position in between. See, 0 to pi, I have an undefined position in between. And so what we're going to do is we're going to start at negative pi over 2 as the beginning of our cycle, our home interval, and stop at positive pi over 2. That's between two undefined values for x. So, and keep that in mind. The tangent function is not defined at this x value nor at this x value. But in between it is defined. We'll actually have vertical asymptotes at these two x values. Now, the next thing I've done is just to illustrate what happens when we get close to those undefined values for the tangent function. And so just to give an idea, pi over 2 is approximately 1.5708. I mean, the decimal goes on forever, but that gives us some idea of that value. And really the significance of what I've done here is not that big a deal. The significance, I should say, is a big deal. So we know that at x equal negative pi over 2, the y value or the tangent function is undefined, and at positive pi over 2 it's undefined. But when I get a number that is close to negative pi over 2, look at my tangent value, negative 1,255. So my y value is way, way, way low when I get to this, close to this x value. And over here, when I get close to pi over 2, see 1.57 is close to pi over 2, but it's not. But when I get close to pi over 2, then my y value is a huge positive number, so it's way, way, way high. And that is another indication, of course, that we have these asymptotes, vertical asymptotes at these two x values. Well, if you recall from the previous page, let me remind you, let's back up to the previous page and let me just get in here real quickly. See, for the x value of negative pi over 2 are undefined, but negative pi over 4, the y value is -1. At 0, the y value is 0. And at pi over 4, the y value is +1. And so that's really what we've done here is we look at this graph. At negative pi over 2 and positive pi over 2, the function's undefined. We have these vertical asymptotes. But when I get close to negative pi over 2, then close right in here, then my y value is way, 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 way low. But at negative pi over 4, which is this x value, then my y value is -1. And if x is 0, we saw previously, the y value is 0. And if x is positive pi over 4, the y value is +1. And when x gets close to pi over 2, like a 1.57, then my y value is way, way, way high. So this is what one cycle, one period of the tangent function looks like. Now this is going to be repeated every pi unit. So if I draw another vertical asymptote pi units away from pi over 2, if I take pi over 2 and add pi units, that would put me right here. I have another vertical asymptote, and so I'll have this cycle repeated in this between these two vertical asymptotes. And if I move to the left, if I go pi units further to the left, that would be at -3 pi over 2, then I'll have this same cycle repeated to the left as well. It goes to the right forever and to the left forever. Unfortunately, I haven't actually extended that graph. I've just shown you that it's going to go through. Notice it goes through the middle. See, it goes through the middle of the distance or the period or the cycle. It has a x-intercept right in the middle of it. So we'll have an x-intercept here, comes up like this, and then goes. Have an x-intercept here, which is right in the middle of this cycle, and so it will go like that. Okay, well, this is a summary of what we need to do, and let me remind you that in our book, I think, we use y equal a times tangent of omega x plus phi, another Greek letter, but it doesn't really matter what we call these letters. We understand that those symbols can be different, of course. Now, we're going to take an attitude similar to the sine and cosine function. We're going to find our home period, and we're going to graph, or home interval, and we're going to graph that one cycle, and then from that one cycle extend it to the left and extend it to the right. In the case of tangent and cotangent, there's not such thing as an amplitude because you don't have a highest place and a lowest place on the graph. But the number a in front will either stretch it out or compress it toward the x-axis. So it'll make it either skinnier, and it won't make it actually any skinnier, but it'll be stretched out and not as curvy, or if a is bigger than 1, or absolute value of a is bigger than 1, and push it toward the x-axis, make it stubbier if absolute value is less than 1. Anyway, we're going to still find our we need to know the period, and that from that we'll calculate the home interval, and we'll go from there. So let's look at what we do here. Now, the period, when we were calculating the period of the sine function and cosine function, we took 2 pi and divided by b, because the purpose, the reason, is that the y equals sine of x and y equals cosine of x, the normal period is 2 pi. So we take 2 pi and divide by this b, or omega. Okay. Well, in the case of tangent function and cotangent function, the normal period is pi. And so when we have a b in front of the x to calculate the period, we'll take the normal period of pi and divide by b. We'll see this in action in a moment. Now, as we just saw with the tangent function, it went between negative pi over 2 and pi over 2, but it was undefined at those endpoints. So that's the reason we don't have an equal part of this less than. So when we're going to consider that our home interval, and so of the regular function, so when we're calculating the home interval of a brand new tangent function, we're going to put it between negative pi over 2 and positive pi over 2 and calculate the new endpoints. Now, cotangent's a little different because cotangent's y equals cosine x over sine x. And sine x is undefined, is 0 at 0, and it's 0 at pi. So cotangent is undefined at 0 and at pi. So it's still a period of pi units, but the basic home period, home cycle or interval, starts at 0 and goes to pi, so we won't have any undefined positions in between. So it's a little different where we start and where we end for the tangent and cotangent, and that's something we have to keep track of. Now, remember that the endpoints of the home interval are not going to be x values of the function because we're not defined. Our tangent and cotangent functions are not defined at these endpoints. That's the issue there. But we'll have vertical asymptotes there instead. But those points are important so that we know we have vertical asymptotes. Then we break that home interval into 4 equal parts, and so there's going to be 3 key x values that are the corner points of the interval. So we're just dividing the home interval into 4 equal parts, and it's the 3 interior parts that we're worried about the graph points for. And then we'll draw the smooth curve indicated by the points. As we approach the vertical asymptotes, we know that we have to go up and down appropriately, way up, way down. And then we'll draw additional asymptotes and cycles as necessary. So that's the idea behind how we approach these. So let's graph, graph y equal tangent of x over 2. Okay, so here's what we calculate the period first. And so we really have to think of the tangent of x over 2 as the same as the tangent of 1/2 times x. So that omega is a 1/2. See, it's 1/2 times x. So, or our b. So we take the original period pi and divide by b or omega. So pi divided by 1/2, and we get 2 pi. So the period of this function, this tangent function, is 2 pi units rather than pi units. Now we need to get our home interval. So we put this argument, the argument of the tangent, we snuggle it between negative pi over 2 and pi over 2, which are the normal endpoints of the normal home interval of the tangent of just x. So now we take this inequality and we solve it for x in the middle. So to do that, we need to multiply through by 2. And as we multiply through by 2, then we'll get negative pi is less than x is less than pi. So our home interval here is between negative pi and pi, as opposed to negative pi over 2 and pi over 2. And you notice there's 2 pi units between these two endpoints. Okay, so it's at these endpoints that we're going to have our vertical asymptotes. Well, I'm having difficulties here. So what I've done here, and it's not showing up for me. I think I'm back in business here. So we take that home interval, and remember we have asymptotes at the 2 endpoints, and between negative pi and pi we break it into 4 equal parts. So halfway between negative pi and pi is 0, and halfway between negative pi and 0 is negative pi over 2, and likewise pi over 2. So it's these 5 points, but asymptotes at either end, and then these 3 interior points are the values that we use when we start graphing. So for these 3 values, we're going to calculate our y value. Okay, so if x is negative pi over 2, remember y is the tangent of 1/2 times x. So if x is negative pi over 2, first we need to know what 1/2 of x is, and that's negative pi over 4. And so the tangent of 1/2 of x is the tangent of negative pi over 4, which is negative 1. If x is 0, 1/2 of x is 0, and the tangent of 1/2 of x, which is 0, tangent 0 is 0. And likewise here, we calculated for x being pi over 2, then we're taking the tangent of 1/2 of x, which is pi over 4, and the tangent of pi over 4 is 1. So it's these y values that go along with these x values. And so that gives us, and notice what I've done here, I've set up my asymptotes between negative pi and pi. There's my two asymptotes, vertical asymptotes. And then at negative pi over 2, which is this x value, I had a y value of -1, so this point. And then at x equals 0, I had this y value, okay, a y value of 0, so 0, 0 is on the graph. And if x is pi over 2, right here, then my y value, which is tangent of 1/2 of x, is a 1, so it's this point. And I know these two are vertical asymptotes, and so I knew my graph had to look this way. And then after I drew this one cycle, then I extended it to the right and extended to the left. So remember, the distance between the asymptotes is pi units. 2 pi units. Negative pi to positive pi is 2 pi units. See, that was our period. So from pi, I had to go 2 pi units, which would be over to 3 pi, to get my next asymptote. And then then I knew that it went through the x-axis in the middle of that cycle. And so that allowed me to get another sketch right here. Likewise, when I went to the left, here's my left asymptote. I needed to go 2 pi units further to the left, which would be at -3 pi over 2. And of course, it goes through the x-axis right in the middle of that. And so that allowed me to get this part of the graph. And of course, it does that forever, left and right. But that's the way we would graph something like y equal tangent of x over 2, or 1/2 x. On the next page, as you see here, we're going to graph y equal 1/2 cotangent of 2x. Okay. So we calculate the period. Now in this case, we take the period, okay, we take pi and divide by b or omega, and then in that case, the b or the omega is this 2. So pi over 2 is our period. Okay, it's a shorter period. And we calculate the home interval. And to calculate the home interval, we put the argument between the normal asymptotes of the cotangent function. But remember, the cotangent function, the normal home interval is from 0 to pi, rather than negative pi over 2 to positive pi over 2. So we snuggle 2x, this argument, between 0 and pi, as you see here, and then we solve for x. And to do that, we divide through by 1/2. And when we divide we divide through by 2, pardon me. When we divide 0 by 2, we still have 0. When we divide 2x by 2, we have x. And when we divide pi by 2, we have pi over 2. So our home interval will be between 0 and pi over 2, which is pi over 2 units long, the period. It will match that period, this distance. Now, the next important part is to take that interval from 0 to pi over 2, and remember, at 0, we will have, at this endpoint, we will have a vertical asymptote. The cotangent is undefined there, cotangent of 2x. And at pi over 2, we will have another vertical asymptote because the cotangent of 2x will be undefined when x is pi over 2. But we still take this interval and break it into 4 equal parts. So I split in half between 0 and pi over 2, I got pi over 4. And then I looked halfway between 0 and pi over 4, and I got pi over 8. And likewise, halfway between pi over 4 and pi over 2, I got 3 pi over 8. This might be the most challenging part of the problem for us, is to figure out these 3 points. Now I'm calculating y, but a little at a time. So to calculate y, I need to know the cotangent of 2x, and then I'll take half of that. But I guess I need to know what 2x is before I can calculate the cotangent of 2x. So if x is 0, 2 times x is 0. If x is pi over 8, 2 times x is pi over 4. If x is pi over 4, 2 times x is pi over 2, and I've extended that all the way across, as you see. Now, the cotangent of 2x, the cotangent of 0 is undefined because the cotangent of 0 is cosine of 0 divided by sine of 0. And sine of 0 is 0, so that would give a denominator of 0. the cotangent of 2x, okay, if x is pi over 8, 2x is pi over 4, and the cotangent of pi over 4 is 1. And likewise, we calculate the cotangent of pi over 2. The cotangent of 2x if x is pi over 4 is 0, because we'd be taking the cotangent of 2x, which is pi over 2. And likewise, we get the same thing. If x is 3 pi over 8, 2 times x is 3 pi over, actually, that should say 3 pi over 4. I just noticed that. This is a 3 pi over 4, not a 3 pi over 2. And the cotangent of 3 pi over 4 is negative 1. And we get over here, if x is pi over 2, 2 times x is pi, and the cotangent of pi, or 2x, would be undefined. So that, again, indicates where we have our vertical asymptotes. Now, the last thing to do is actually calculate y, because y is 1/2 times cotangent x, and so all you're seeing is my y value is 1/2 of the values here. Well, if it's undefined, it's still undefined, but 1/2 of 1 is 1/2, 1/2 of 0 is 0, 1/2 of negative 1 is negative 1/2, and 1/2 of undefined is still undefined. So we have vertical asymptotes at x equals 0 and pi over 2, and every pi over 2 units each direction. Now, the cotangent function, see, the tangent function goes up from left to right. The cotangent function goes down from left to right, and you can see it happen right here. Now, we have a vertical asymptote at x equals 0, which is the same as the y-axis, and so I didn't put that in there. But we also have a vertical asymptote at pi over 2, and that's right here, okay? And then we found out that the cotangent of, and remember, I split that into 4 equal parts, so I had an x of pi over 8, say right across here, pi over 8, pi over 4, 3 pi over 8, pi over 8, pi over 4, and 3 pi over 8. And when x was pi over 8, I found out that y was 1/2. Well, if this is where y is 1, this is where y is 1/2. That's the point pi over 8 comma 1/2. And when x was pi over 4, I found out y was 0, so it's this point. And then when x was 3 pi over 8, right here, we found out our y is negative 1/2. And here's negative 1, so this is negative 1/2, so it's this point. And so as we're drawing that graph, it's coming down rather than going up. Now, we would continue, and I haven't done it here, but we would go another pi over 2 units. See, what's pi over 2 plus another pi over 2, because the period's pi over 2, that would take us to pi, wouldn't it? So we'd have another vertical asymptote at pi, and then we'd have a matching cycle here. And if we went this direction, pi over 2 units, over to negative pi over 2, we would have a matching cycle there, and it goes forever to the left and to the right. Well, that ought to give you a good start to these tangent function and cotangent functions as you're graphing. So good luck to you. The next thing we'll do after this, in the next section, we'll talk about phase shift.